So 3.4 is using the quadratic formula. Remember quadratic formula from Algebra 1, you probably learned it's like the Pop Goes the Weasel song. It's x equals negative b plus or minus square root of b squared minus 4ac divided by 2a. So, or all over 2a. The quadratic formula just helps you find the solution to any quadratic equation, even if the solutions happen to be imaginary solutions. So this is for when you can't factor it, it would be difficult to solve by completing the square, you're left with quadratic formula, or you can't solve by square roots either. So for example 1, it says solve by using the quadratic formula. If you remember from Algebra 1, solving by quadratic formula is just kind of like a lot of plugging in numbers and simplifying. So, but in order to figure out what a, b, and c are, what all those variables are, you need your quadratic to be in standard form. So like ax squared plus bx plus c equals 0 is standard form. So everything should be on one side of the equal sign, and it should be equal to 0. So for 1a, we have 3x squared plus 4x equals 10. So it's not in standard form right now. I need to subtract that 10 over. And then I'm left with 3x squared plus 4x minus 10 equals 0. And then now I can see what a, b, and c are pretty easily. So a is the coefficient of x squared, so a is 3. B is the coefficient of x, so b is 4. C is the constant, so c is negative 10. Then I just need to take each of those values and plug them into our quadratic formula. So x equals negative b, so negative 4 plus or minus square root of b squared, so 4 squared, minus 4ac, so 4 times 3 times negative 10. And then all over 2 times a, so all over 2 times 3. And then from there, you're just simplifying in order to get to your final solution. So you want to start by simplifying what's inside the radical first. So negative 4 plus or minus the square root of 4 squared, so 16. And then minus 4ac. So 4 times 3 is 12 times negative 10 is negative 120. So this is like minus negative 120, so it turns into plus 120. And then over 2 times 3, so over 6. We can add inside the radical, so equals negative 4 plus or minus 16 plus 120, so 136 over 6. And then from there we need to figure out, or we need to simplify that radical. So like 136, I know it probably has a perfect square factor somewhere in there, so I can check to see, like the smallest perfect square factor I could check for is 4. And it's divisible by 4, and then think like, does 34 have any perfect square factors? No, it's just like 1 and 34 and 2 and 17. So you wouldn't be able to simplify the square root of 34 anymore. So because 4 is a perfect square factor of 136, that means that we can pull that 4 out and take the square root of that 4. So this will become negative 4, and then plus or minus, when I take the square root of the 4 factor, it'd become 2 times the square root of what's left, which is the 34, over 6. And then your very last step would be to kind of like reduce the fraction if you can. So you can't do this until the very, very end. Like this mistake is pretty common where people try to do this during this step, where they want to reduce or like try to get smaller numbers and stuff like that. You can't do that till the very end until you've simplified the radical. So basically, because this negative 4, this 2, and this 6 are all divisible by 2, I can divide a 2 out. So if I divide a 2 out, it's essentially reducing the fraction. So if you don't divide the 2 out, it's not fully simplified. That would like be giving an answer of 2/4 instead of 1/2. It's not simplified. So if I divide the 2 out, negative 4 divided by 2 is negative 2 plus or minus 2 divided by 2 is just 1. So I can write the 1, or I could just leave it alone. Just like keep it off, kind of like writing 1x instead of just x, or x instead of just 1x. and then over 6 divided by 2, so 3. So this would be your final simplified answer. And then, like I said, this mistake of like trying to reduce too early happens pretty frequently, but the reason you can't is like you can't just divide these two numbers by 2 because you would need to be able to divide this like radical term by 2 also, and you can't until you're able to pull this 2 out in front. And then for B, it's 4x squared plus 3x equals negative 13x minus 16. So same thing, we want to get it in standard form first. So we can add the 13x over. So 4x squared plus 3x and 13x together is 16x equals negative 16. And then I want everything on one side of the equal sign equal to 0. So I can add that 16 over. So I end up with 4x squared and then plus 16x plus 16 equals 0. And then from there, if you have a common factor that you can divide out, it makes it easier if you do that. So like all of these are divisible by 4, so I can either factor out the 4 or I can just divide it out since it's an equation. So everything is divisible by 4, so I'm going to divide it out. As long as you like divide the entire equation by 4, you're not actually changing the value of it. So 4x squared divided by 4 is x squared, and then 16x divided by 4 is 4x, and then 16 divided by 4 is 4 equals 0. And then this looks like it's actually factorable, but for the sake of using the quadratic formula, why not? We'll kind of see how that final answer looks at the end, and we'll see why it was factorable. So A is going to be 1, the coefficient of x squared, B is 4, and C is also 4. So if I plug those into the quadratic formula, I have x equals negative b, so negative 4, plus or minus square root of b squared, so 4 squared, minus 4, times a, so times 1, times c, so times 4. And then all over 2a, so all over 2 times 1. And then if I simplify, negative 4 plus or minus 4 squared is 16. And then minus 4 times 1 times 4, so minus 16. And then all over 2. So negative 4 plus or minus the square root of 0 for 16 minus 16, and then over 2. And then the square root of 0 is still 0. So this ends up just being negative 4 over 2, which is negative 2. So you can still, like any question, like any problem that you could factor, like x squared plus 4x plus 4, you can still get the solution like by using the quadratic formula. Like if we had factored this, this would factor into like x plus 2 times x plus 2. So you can just set those factors equal to 0 and end up with x equals negative 2. And it's just a lot more efficient to factor it, but you can still get to the same answer by using quadratic formula. I don't want to recommend using quadratic formula for everything like at all. I would factor if you can factor it because you want to save yourself some time. You don't want to have to do more work than you have to. Just know that it is always a backup that you can use if you're like struggling to see the factors. So for C, 5x squared plus 2x equals 1. We need it in standard form, so I need to add that 1 over. So 5x squared plus 2x plus 1 equals 0. Now I can figure out what my a, b, and c are. So a is the coefficient of x squared, so it's 5. B is 2. And c is 1. So x equals negative b, so negative 2, plus or minus square root of b squared, so 2 squared minus 4 times a times c, so times 5 times 1, divided by 2 times a, so 2 times 5. Then I can start simplifying inside the radical, so negative 2 plus or minus square root of b squared, so 4, minus 4 times 5 times 1, so minus 20, and then over 2 times 5, so over 10, negative 2 plus or minus, if I do 4 minus 20 inside the radical, it's negative 16, so the square root of negative 16 over 10. So if I stop right here, I'm not far enough along in the problem to reduce this. So I can't just be like, oh, 2 and 10, I can divide them both by 2, so I should do that. You can't do that till the very end. It should be your very last step every single time. So negative 2 plus or minus the square root of 16, or negative 16, I can take the square root of negative 16. So that would be plus or minus 4i, because it's a negative, and then over 10. And then now I can go ahead and reduce it because all 3 terms that are there are able to divide by 2. So because the negative 2, the 4, and the 10 are all divisible by 2, I can go ahead and divide by 2. So when you do that, you end up with x equals, if I divide negative 2 by 2, I get negative 1, plus or minus 4i divided by 2 would be 2i, and then 10 divided by 2, so over 5. Okay, so the discriminant. The discriminant is the section or the part of the quadratic formula that's underneath the radical. So it's only the b squared minus 4ac. And what the discriminant does is it tells you how many real solutions that you have versus like imaginary solutions. So if you have a positive discriminant, so if b squared minus 4ac is greater than 0, that means that you have 2 real solutions. That also means that you have 2 x-intercepts. If the discriminant is equal to 0, that means you have 1 real solution. So if b squared minus 4ac is equal to 0, you have 1 real solution. And you also have 1 x-intercept. And then if you have a negative discriminant, you'll probably be able to guess it. B squared minus 4ac is less than 0. You have like 2 imaginary solutions, no real solutions, and no x-intercepts. So you have 2 imaginary solutions, so solutions that have an I in them. You have no real solutions. And you have no x-intercepts. So what that looks like on a graph is if I have a positive discriminant, that means that my graph is going to have 2 x-intercepts. So it's going to cross through the x-axis at 2 places. The graph could be in any location. It doesn't have to be right there. It could be flipped upside down. But as long as it crosses the x-axis in 2 places, it has a positive discriminant, has 2 x-intercepts, 2 solutions, 2 real solutions. If your discriminant is 0 and you only have 1 real solution, your graph is going to look something like this, where the vertex is on the x-axis. That's the only possible way for there to only be 1 real solution. That's when the vertex is on the x-axis. And if you have a negative discriminant or if you have no real solutions, that means that the graph does not cross through the x-axis at all. So, and the reason why, like, to try to make that kind of connection, it's not really like, oh, I have to memorize that, like, positive discriminant has 2. Like, there's a very good reason why. So, like, if we wanted to find, like, for example, I'll go back to the page we wrote on. So, like, for example 1a, if we were to find the discriminant on here, so, like, the discriminant is just b squared minus 4ac. If I were to plug in b, that would be, actually scratch that, we don't even have to. When we found the discriminant, basically when we simplified inside the radical, we got 136 from my b squared minus 4ac. I got positive 136, and because of that I ended up with 2 real solutions. So even though this is not necessarily a clean solution, it's a real solution because it doesn't have I. And anytime, like, what would cause the I is if I had a negative inside the radical. So, like, for C, I ended up with a negative inside the radical, and my solutions were imaginary. So if what's inside the radical is positive, you end up with 2 real solutions. If it's negative, you end up with 2 imaginary solutions. And if it's 0, like it was here, you end up with 1 solution. Because you're not adding, like, there's no plus or minus a number. It's just you're adding 0, so it doesn't make a difference whether you're adding or subtracting it. So there may be, like, some questions where you're just asked to find the number and the type of solutions, and that's where you could just use the discriminant. You don't have to, like, use the whole quadratic formula. So for A, or 2A, it says find the discriminant and describe the number and type of solutions of the equation. So if we need to find the discriminant, we just have to figure out what A, B, and C are and plug those values in or sub those values in. So A is 25, B is negative 20, just the coefficient of x, and then C is 4. So I just need to find b squared minus 4ac. I don't need to worry about the entire quadratic formula because I'm not asked for the solution, I'm asked for the number and type. So b squared is going to be negative 20 squared minus 4ac, so minus 4 times 25 times 4. And then negative 20 squared is positive 400. And then 4 times 25 is 100 times 4 is 400. So this is minus 400. So 400 minus 400 is 0. So you have 1 real solution. And then for B, same thing. If we want to find the number and type of solution, but not worried about what the actual solution is, just have to identify what A, B, and C are. So A is the coefficient of x squared, which is 1. B is 2, and C is 6. So b squared minus 4ac is our discriminant. B squared is going to be 2 squared minus 4 times 1 times 6. 2 squared is 4, minus 4 times 1 times 6, so minus 24. 4 minus 24 is definitely negative, it's negative 20. So since the discriminant is negative or less than 0, there's 2 imaginary solutions and no real solutions. Oops, not real. 2 imaginary solutions. And then for C, x squared plus 2x minus 3. So we have to find A, which is the coefficient of x squared, that's 1. B is the coefficient of x, which is 2. And then C is the constant, so negative 3. So b squared minus 4ac. B squared is 2 squared minus 4 times 1 times negative 3. 2 squared is 4 minus 4 times 1 times negative 3, so that's like minus negative 12, so plus 12, which is 16. So since we have a positive discriminant or a discriminant that's greater than 0, we have two real solutions. And then example 3 says the height h in feet of an object above the ground given by h equals negative 16t squared plus 64t plus 190, where t is the time in seconds. Find the height, find the time it takes the object to strike the ground and find the maximum height of the object. So if we want to find the time where the object hits the ground, or yeah, find how much time it takes, I'm going to do this on a separate sheet of paper, but find the amount of time it takes for the object to hit the ground. The height is going to be given by h, so we just need to take h and replace it with 0, because the ground's height is 0. So we're just plugging in 0 for h or substituting 0 for h and solving the equation. So instead of h equals, it'll be 0 equals, because we want to find out at what time t the height h will be 0. So 0 equals negative 16t squared plus 64t plus 190, and then we just have to figure out a way to solve this. So you can take all these numbers, like take a, b, and c, and substitute those into the quadratic formula if you want right away. You can divide out a common factor if you want to. So I know for sure that 2 can be divided out because they're all even numbers. So just to like save me some work later on, I'm just going to divide out a 2 now. If you don't do that first, it's like you'll still get the right answer. You'll just end up having to simplify bigger numbers inside the quadratic formula. So if I divide out the 2, I'm left with 0 equals negative 8t squared, and then 64 divided by 2, so plus 32t, and then 190 divided by 2, so I think plus 95. And then from there, that'll be my new a, b, and c. So a would be negative 8, b would be 32, and c would be 95. So I can take all those values, I can plug them into my quadratic formula. So x equals negative b, so negative 32, plus or minus the square root of b squared, so 32 squared, minus 4 times a, so times negative 8, times c, so times 95, and that's all over 2 times a, so 2 times negative 8. So I'll start by just simplifying inside the radical, so negative 32 plus or minus the square root. 32 squared is 1024. And then minus 4 times negative 8 times 95. So that would be like minus a negative 3040. So it'll turn into plus 3040. And then that's all over 2 times negative 8, so negative 16. And then negative 32 plus or minus the square root of 1024 plus 3040, so 4064, and then all over negative 16. So still too early to try to reduce this. We have to first try to simplify this radical. So obviously that's a really big radical to try to simplify, so I think the best thing that we can really do, actually I'm gonna stop there. For modeling questions, so for like when they ask you the time, or yeah, like how much time it takes, specifically for modeling problems like this, I'm fine if you just like take the square root, like actually take the square root in your calculator instead of simplifying the radical, because if someone were to be like, oh, how much time is it going to take? And you were like, oh, negative 32 plus or minus some radical, I don't think they would have any idea what you mean. So just change it to a decimal for like the word problems themselves. Every other problem, you need to simplify the radical. So this is going to be negative 32, and then if I want to take the square root, every calculator is different, but like usually it's above the x squared button. So you hit second, and then this x squared button, and then 4064. And you can cut it off at just one decimal place is fine. So plus or minus 63.7, and then over 16, negative 16. And then from there you have to create two different equations, like one with the plus 63.7 and one with the minus. So we'll do x equals negative 32 plus 63.7 over negative 16, and then x equals negative 32 minus 63.7 over negative 16. It is really important that you do both, because one of them isn't going to end up being a valid, because it'll end up giving you a negative time. So if I do negative 32 plus 63.7, I get 31.7 divided by negative 16. And then 31.7 divided by negative 16 is negative about negative 1.98 seconds. And then for the second equation, negative 32 minus 63.7 is negative 95.7 over negative 16, and then if I divide that by negative 16, I end up with x is approximately 5.98 seconds. So it doesn't make sense for us to have a negative time. So the time it takes for it to hit the ground is going to be 5.98 seconds. The reason there's two answers is because like it's shaped like a parabola. Like when the object is, what is it? It's flying through the air. So it's flying through the air, and at some point it hits the ground. It hits the ground for the second time at the 5.98 seconds. The fact that the first time was negative 0.98, that's still a solution. It's just like that is telling us that like the object started above ground, basically, if there's a negative time like that. Okay, so that's the answer for the first part, and then it also asks what's the maximum height of the object, which kind of takes us back to section, I think 2.2 or something. So if I want to find the max height, that means I have to find the vertex. So I'm just going to rewrite the equation. The equation itself was, it was h equals negative 16t squared plus 64t and then plus 190. So if you remember back to section like 2.2 or whatever, I think it was 2.2. In order to find the vertex, when it was in standard form, we first had to find the axis of symmetry, so it's the same thing here. So that'll be, instead of x equals, it would be like t equals, since we're using t instead of x. So t equals negative b over 2a, so same thing. So negative b would be negative 64 over 2a, so 2 times negative 16. This would be negative 64 over 2 times negative 16, so negative 32. And then this would reduce negative 64 divided by negative 32 would be 2. So this tells us like the x-coordinate of the vertex basically. To find the actual height though, like the y-coordinate of the vertex, I would have to take that 2 and plug it back in for t. So h is equal to, it's going to be negative 16 times 2 squared. And then plus 64 times 2 plus 190. So negative 16 times 2 squared would be negative 16 times 4. 64 times 2 would be plus 128 plus 190. Negative 16 times 4 is negative 64. Plus 128 plus 190. And then if you add all those together, you end up with 254. And then the height is in feet, so the max height is 254 feet. And then for example 4, it says a foul ball leaves the end of the baseball bat and travels according to the formula h of t equals 64t minus 16t squared, where h is the height of the ball in feet and t is the time in seconds. How long will it take for the ball to reach the height of 64 feet in the air? So if we want to figure out how long it's going to take for the ball to reach a specific height, like on example 3, we were trying to figure out how long it took for it to hit the ground, which also is a specific height. It's like a height of 0. And we took 0 and we replaced h with it, and we solved that equation that way. So now if I want to figure out how long or how much time it takes for the ball to reach a height of 64, I still have to take that 64 and plug it in for the height. So the function itself is h of t equals 64t minus 16t squared. So I can take that h equals 64, or we'll say h of t equals 64 feet, and I'm going to sub that in here. So 64 equals, we could do 64t minus 16t squared. And then now if I want to solve this, I need to get it in standard form, so I have to subtract this 64 over. So 0 equals, I'm also going to reorder this equation, so I'm going to move the negative 16t squared forward. And then plus 64t minus 64. And then now I can check to see, is there a number that I could divide each of those by? Obviously I can divide them all by 2. Looks like I can divide them all by 4. But 16 is also a factor of 64, so I can divide everything by 16. I kind of want to check to see if this is factorable, and I like to factor, everybody likes to factor when a is positive. So I'm going to divide the entire equation by negative 16. So if I divide the entire equation by negative 16, be 0 equals negative 16 divided by negative 16 is t squared, and then 64t divided by negative 16, that would be minus 4t, and then negative 64 divided by negative 16, that would be positive 4. So now I have 0 equals t squared minus 4t plus 4. So even though like this is the quadratic formula section, I don't really like want to just like force you to do the quadratic formula if you don't have to. So like anytime you are working through a problem, and you, even if it starts off like with larger numbers like this, if you can simplify it down to smaller coefficients, check to see if it's factorable. Like, so whenever you're checking to see if something's factorable, you're looking for factors of a times c that add up to b. So like a is 1 and b and c is 4, so a times c is going to be 4. And all their factors of 4 that add up to b, which is negative 4. You could use negative 2 and negative 2. So that means that this is factorable, and like I don't see the sense in like just because it's this section like forcing the quadratic formula. So factor it. It's faster, it's more efficient, and that's the purpose of math, is to become more efficient at completing problems. So 0 equals, because this is factorable, the factors of 4 that add up to negative 4 are negative 2 and negative 2. So this factors into t minus 2 times t minus 2, or you could do t minus 2 squared. And then you set each factor equal to 0. Obviously they're going to create the same solution, so just write it once. t minus 2 equals 0. And then you end up with t equals positive 2. So I think this one's in terms of seconds also. I can't read it first. Yeah, there we go, seconds. So t equals 2 seconds. If you want to use quadratic formula, you're welcome. But if you recognize this about like any of the problems in this homework, you're welcome to just factor it if you're able to. Okay, so example 5 is solved by using any method, and then I believe that's the last of section 3.4. So solve using any method. The first thing typically that you would want to do is get it in standard form. Depending on the problem, obviously every problem is different, but get it in standard form to check to see if it's factorable. So like 7x squared plus 7 equals 14. I want to get this in standard form, so I'll subtract the 14x over. Get 7x squared minus 14x plus 7 equals 0. And then everything's divisible by 7, so I should divide out a 7. And then when I divide out a 7, I end up with x squared minus 2x and then plus 1. So now you have to think, are there factors of positive 1 that add up to negative 2, since a is just 1? So there are. Those factors would be negative 1 and negative 1. So that means that this factors into x minus 1 times x minus 1, or x minus 1 squared, however you want to write it. And then from there I can solve. I can set each factor to equal to 0, but since they're the same factor, I'm just going to write it once. X minus 1 equals 0. Add 1 to both sides and get x equals positive 1. So that's why we push factoring first, is because it really is the fastest way to solve a problem if it's factorable, especially if a is 1. And then for example 2, you have x squared plus 2 equals negative x, so I want to get that in standard form, so add the x over. So I have x squared plus x plus 2 equals 0, and a is 1, so now I'm just seeing if there's factors of 2 that add up to 1. There's not. There's no way you could do that, because it's just like the factors, there's no way to get either 1 and 2 to add up to 1, or negative 1 and negative 2. So if it's not factorable, then you can either solve by completing the square, or you can use quadratic formula. So if the a value is 1, and especially if the values in the equation are fairly straightforward, it's not so bad completing the square. So when you have, I'm going to push that because I think solving the quadratic formula is pretty straightforward if you wanted to do it that way. So if I want to complete the square, I have to move the 2 over, so subtract 2 from both sides. And then I have x squared plus x equals negative 2. And then to complete the square, you have to add b over 2 squared to both sides. So b is 1, so 1 over 2 squared. So that means I have to add 1/4 to both sides to complete the square. So it's x squared plus x plus 1/4 on this side, and then negative 2 plus 1/4 on this side, and then keep writing it up here. And then remember, when you complete the square, there's a pattern. It factors into x and then plus b over 2, all in parentheses squared. So this factors into x plus 1/2 squared. And then if I want to get common denominators on this side, I'm just going to make a little side note over here. So negative 2, if I wanted it to be over 4, that would be negative 8 over 4 plus 1 over 4. So if I add those two together, I get negative 7/4. And then now I can square root both sides. So the squared cancels out the square root, vice versa. So I have x plus 1/2. And then I can simplify this radical, so the square root of negative 7 would be plus or minus just I, and then root 7, because the square root of 7 itself can't be simplified because it's negative. I can pull out an I. And then over the square root of 4, which is 2. And then I can subtract the 1/2 over. And since these denominators are the same, I'll have like a nice clean answer. It'll be x equals -1 plus or minus I root 7 over 2. And then for example 3, x squared plus 20x equals 8. So I want to, you can check to see if in your head if it's factorable or not. Like if I subtract this 8 over, then c would be -8, and I would be looking for factors of -8 that add up to 20. So there's no factors of -8 that add up to 20, like 1 and 8, 2 and 4. There's no way to get that to add up to 20. So that means my options are completing the square and using the quadratic formula. It's already like set up for you to complete the square. So you don't have to do any work to set it up, and it's probably even easier than number 2 to complete the square. So b is 20, so b over 2 squared would be 20 over 2 squared. So 10 squared. So I have to add 100 to both sides to complete the square. So I'm going to add 100 to both sides, so x squared plus 20x, and then plus 100 right here, and then 8 plus 100 on the right side, so 108. You can factor this. It factors into x plus b over 2, so b over 2 itself was just 10, so x plus 10 squared, and then equals 108. And then also remember like the pattern, if you don't remember the b over 2, like it's the square root of the first term, the sign for the middle term, and the square root of the third term. So like square root of x squared is x, sign of the middle term was positive or plus, and then the square root of the constant was 10. And then now I can square root both sides. So if I square root the left side, that becomes x plus 10. And then the square root of 108, I know for sure that that can be simplified. So I know that 9, like 108 you can divide by 9, but then you get 12, and 12 still has a perfect square factor. So because like 9 is a perfect square factor and 4 is also a perfect square factor, that means that 36 is going to be a factor of 108, because 9 times 4 is 36. So you do 108 divided by 36 and you get 3. So since you can divide 108 by 36 and get 3, that means if you wanted to simplify this radical, you could take the square root of 36, which would be plus or minus 6, and then you're just left with 3 inside the radical. And then now you can subtract the 10 over. So x equals -10 plus or minus 6 root 3. Okay, and then last one, we have 3 times x minus 2 squared minus 5 equals 1. So we have something being squared. We would have to do a lot of work to get this in standard form. And because I just have like this one term that has the x, instead of like there's no x over here or over here, I can easily isolate that term that has the x and take the square root of it in order to solve it. So if I want to isolate the part that is being squared, the x minus 2 squared, and solve by square roots, I need to move everything away. So first I can undo the subtraction. I can add 5 to both sides and get 3 times x minus 2 squared equals 1 plus 5, so 6. And then I want to get rid of that 3 because I don't want to square root the 3. Divide both sides by 3. And get x minus 2 squared equals 2. And then now what is being squared is by itself, so I can square root both sides. So x minus 2 and then equals just positive or negative root 2, because I can't simplify the radical. at all. And then I can go ahead and I can add 2 to both sides. So x equals 2 plus or minus the square root of 2.